This is TWIS. This Week in Science, episode number 966, recorded on Wednesday, April 3rd, 2024. Want to hear about science junk? I know you do. I'm Dr. Kiki, and tonight we are going to fill your head with barcodes, bacteria leather, and junk. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience. Disclaimer, disclaimer, disclaimer. What goes on in your brain is never the same from moment to moment, from day to day, from year to year. As you experience things, your brain is commandeered by sensory cascades, by behavioral tirades, causing feedback loops that go on and on and on and on and on and on. And just like This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science, everyone, and welcome to another episode of This Week in Science. We are back again to talk about all the science that we want to fill your heads with. It's been filling my head all week long, so I got to share it, got to get it out somewhere. Thank you so much for joining us. The show ahead is full of fun, and once again, I am joined by the incredible, the amazing, the fantastic Dr. Jessica Hebert, placental biologist working at OHSU, Oregon Health and Science University here in Portland, Oregon. Also a member of the PDX Broadsides, wonderful band who has shared a stage with us in shows past. Jess, thank you so much for joining me again. What is going on? It's been like 2 weeks. We went like 4 years without talking, and now it's 2 weeks. Here we are talking again.
Yeah, basically, I don't know, but I love this trend for us, and we should persist. And I told Fada that when I hit the five-time club for hosting, I do demand a smart blazer.
Oh, like SNL.
Yeah, exactly.
We're gonna have to.
Now I have a goal.
Oh,
So
this is a new idea. I'm liking it. Okay.
Good. Yeah.
Blazers.
A blazer.
I love it.
Merch ideas. This is what I bring to you.
Yeah, but I'm trying to figure out now. I'm like, who has been on the show aside from me, Blair, and Justin 5 times?
I don't know. That's a hard one. I think this is my 4th time.
So you're
I know.
so close. Oh my
We're
gosh.
so close. So
You might
close.
be there in competition with Tom Merritt. He would be the other possibility, I think. I don't know.
Then I'm
Right.
very good.
TWIS chat room brain. Think who may have who may be the 5-timers club. Oh, this is so much fun. I have stories that I've brought tonight about some transistors made of molecules, some legs, or maybe they're junk. I don't know. You got to tell that one. Yeah.
Okay, no los dos.
The speed of vision, some barcoding birds. We've also got some naked mole rats who've got real heart. What you should do to vent that anger, like I said in the early show, bacteria leather. And to end the show, we're going to talk about a really disturbing robo mirror. And Jess, I can't wait to hear your comments on all of these stories.
I will provide comments. I did think of you this weekend. So back, which episode was it that twisted the Alberta Rose Live show?
I don't remember episode numbers, but I do know that it was 2019 because 2020 was the pandemic and it was pre-pandemic. So
Go look up the episode. It's super fun. Everybody in the chat. My band, the PDX Broadsides, did like live music, but
It was
it was so
amazing.
fun to be on that stage. And you and Blair and Justin did an amazing job that night, and the audience was fantastic. But I was performing at the Alberta Rose this weekend, and then got to think of you to be back there and in that green room where I learned a very interesting fact from you while we were back there. I don't remember if you remember
Did I
telling me
tell
this.
you?
You told me that it takes 30 seconds for all animals to poop.
That was a study that had recently come out, and
You were so excited about it, and I have never forgotten that fact. And so I'm in the back green
so
room at the Alberta
controversial.
Rose with a bunch of aerialists who are like warming up, and some hoop people, and the suspension
And
person
some
that I
poop
mentioned
people.
the last time I was on. And I got to talk to her about the physics of body suspension while she does opera. It was amazing. It was
So
amazing.
cool.
Yeah, she does it under operification. It was one of the most incredible things I think I've seen on a stage in a long time. It
I
was
want to.
really.
I'm sorry I missed that. That sounds really amazing.
I think there's a video of it, and I'll send it to you. But like hooks in your flesh, and you're up in the
wait.
air.
Oh, that's like Jim Rose sideshow theater kind of like.
Yes,
Yeah.
and
Okay.
spinning as she's doing ritual opera.
Wow.
It was. I've never seen anything like it. It was incredible. But I thought
there is a lot of science there.
And I'm telling people, the last time I was here, I learned that all animals poop in 30 seconds. So this is a different experience. Fada says that the Alberta Rose Live TWIS was 5 years ago today.
What? Fada?
I don't know how that's possible.
Today, because of Science Talk, because it happened during the annual Science Talk Science Communicators Conference.
That's
and
crazy.
it's around this time of year. So, oh my gosh, welcome back. 5-year anniversary, if not 5-timer club.
Well, I will accept the cashmere scarf instead until we get up to the blazer level.
That's right, with the TWIS cashmere, which is yes.
Yeah, no, I love this show. It's such a pleasure to be back.
Well, everyone, if you are enjoying being here and this show, and you know people that really should like the show, I want to remind you that they can subscribe to the podcast anywhere good podcasts are found. Look for This Week in Science. We also live stream Wednesdays, 8 p.m. Pacific time, YouTube, Facebook, and Twitch. And if you hit that little notification bell, in addition to subscribing, you're going to get notified when we go live. You can also just look for This Week in Science all over the internet to find stuff about us. Our website is twis.org, and new episodes are there with show notes every week, thanks to our editor, Rachel. But now, okay, you ready for some barcoding birds?
Totally.
All right, let's dig into the birds. So this story is top of my list tonight because I studied bird brains for my PhD, and chickadees were one of the species that lived in the lab where I lived, basically, to do my PhD. And I went doing field work, studying chickadees and the chickadees, and their little call. And so learning and memory was my field of study. And this study, published in the open access 50 Cell right now, it's on Cell Online. Researchers out of Dmitry Aronov's lab, and I believe it's at Columbia University, have been working on understanding what's called episodic memory through the lens of these birds as a model species. So episodic memory is the where, when, like the who, what, where, when, how of a moment. So right now I can say, I'm in my studio and it is about 8:15 p.m. and I'm hanging out with Dr. Jess, and I got my chat rooms going and I'm talking about science and all this stuff, and I've got a light in my face, and there's a lot of stimuli that come together to create a moment that can become a memory. And you know how like habituation is the problem of things being the same all the time, and your neurons don't respond the same way anymore. And so you might do the same thing every morning, and then when you do something a little bit different, your brain doesn't really pay attention, and so suddenly you lost your keys, or your eyeglasses are up on top of your head instead of on your face, and you're looking for them, or you put your coffee cup somewhere and you don't remember where you put your coffee cup. So your brain is trying to parse all this information, and there are a few hypotheses as to how the brain does it and how episodic memories get formed. The hippocampus is the part of the brain where, after the limbic system and the emotions and the sensory stuff comes through, the hippocampus is like, let's take this information and we're going to turn it into something that's a memory. And we're going to send it to the rest of the brain for storage. And so the hippocampus is like, signal, signal, signal. What kind of signal am I going to make? And the hippocampus in humans, mammals, is like between our ears, deep in the middle of the brain. But in birds, it's at the very, very top of the head. So birds are awesome because they have very thin skulls, and you can access their hippocampuses very easily because they're right on top, similar to the reptile brain, like lizards and others. Okay, so cool aspect of this study. They did recording from chickadee brains while the chickadees were hopping around a room and storing food, and then going back to get that stored food at another time. So the storing of food is known as caching, and then cache retrieval is when they go back and get it. And it's just, honestly, I have always loved chickadees, and they are part of the Paridae family. Paridaes are also, there's the great tit, there's lots of tits, and the Siberian tit is a bird that lives very, very, very far in the Arctic North, and they are known to store up to 250,000 items over a fall-winter season for survival.
Yeah, you have to.
Right. And chickadees, depending on which subspecies of chickadee we're dealing with, some of them can store up to 5,000 items a day at times. So, like, seriously, that's like, hey, I'm going to take my milk, put it over here. I'm going to take my apples, put it over there. I'm going to take some peanuts. I'm going to put them over there. Oh, my spinach, that's going to go over there. I mean, you put them all over the place, all over your house, all over wherever. And then you're like, oh, I'm hungry. Where do I go? They don't just have a refrigerator in the kitchen. They have to go back to all those different places and remember where they were. And so in this study, in recording from the brains of these active birds, which this is a technological advance. This in itself, being able to put electrodes into the brains of these birds so that they could be independent and active, and have these are tiny brains. So you have to have little tiny electrodes. And so the resolution, the ability to actually resolve individual neuronal activity is like, it's like the scale of stuff has gotten so tiny compared to when I was in graduate school. This is what they're doing is beyond.
Yeah.
Like, to me, that in itself is an advance. But they got these birds, and in the letting them run around this kind of what they call an ethological paradigm. They've got a little space where the birds can hop around, and there's little places that the birds can put things. And, they thought that maybe there are these cells in the hippocampus that are called place cells that respond to particular places. They thought one hypothesis was, okay, the place cells are going to play a role in part of the design of the neuronal activity that takes place. The other hypothesis is that the place cells do not play a part in it at all, and there are other parts of neuronal activity that are important. And so for these birds, they used high resolution cameras to resolve the motion of the birds, their body orientation, to determine whether or not they were just poking at a potential place to put something or whether they actually stored something there. And then they gave them an opportunity to go back into that area where they had stored lots of stuff and go back and find things. And in the searching for places to store, when they stored something, there was a very specific set of neurons that fired together in a very specific way. And then when the birds went back and retrieved what they had stored, the exact same neurons fired again. So it was an exact replay of what had happened when they were initially storing.
That's so cool.
Yeah. And the fact that like these birds, they're just, you can't even tell. They got feathers on their heads. They're going around. They're doing their business. These birds are storing food. I have, this to me is magic.
I'm no stranger to like small animal surgery because I do transmitter probe insertion in mice, and so having to line things up their carotid. I've done some brain work, but doing this in chickadees, that's super delicate work. That's so cool.
Very delicate. And like these birds are, I mean, they're really wonderful birds. But because of the signals and the activity that has been identified and the fact that it is a retrievable code, they're calling it a barcode because it's very identifiable. It's a very short burst of activity, but it's a whole set of neurons that are firing kind of in this pattern at the same time.
Yeah.
Now what they don't know, so what they did find is that the place cells, even though there are like lots of spots where the birds could have used different cues to hide things and figure things out, the place cells were never active. Place cells were completely constant throughout. So the next question is the paradigm they put the birds in too small and too just kind of, it's like just one room, right? It's like you get used to being in one room and that's just the room, that's the place. And so did the birds' place cells habituate before the experimentation even took place? And so the place cells were just like, meh, whatever. And it was other neurons that were taking place in the activation. Or, so if they gave them different rooms to cache in, would that change? And would the place cells then become active as part of this barcode? That's one question. Another question that they did not answer is planning. So what happens in the birds' heads when they go, I'm hungry, I want to go get something? Do they have a spurt of activity that is that exact barcode that then leads to the behaviors and the motor activities that send them to the place? Or is it that they're just passing by a place and because it's familiar, the barcode, the neurons fire, and that is what starts the activity? So they don't know how planning is involved in this or if planning is involved in it.
Yeah. In a room like that where safety is kind of equal across versus, you're in the wild, a tree or a bush might be more protected versus, I wonder what that looks like.
Yeah, and there have been studies with pigeons and lots of other birds where you have like larger navigational cues, and there are different parts of the brain that are involved in the more general navigation. And then when you get to very local navigation, that shifts. And so there are different neurons and different brain networks involved in different types of navigation. It's like, going from San Francisco, California to Portland, Oregon, you kind of know, just head north, keep the sun in a certain place, for 11 hours. And then when you get to Portland, you have to figure out the right neighborhood to go to, the right street, the landmarks. And so identification and the brain activity is very different. But anyway, I love this study. I think it's just one of the coolest things that I have come across recently because chickadees and the hippocampus. And yeah. So, does this happen in our brains in the exact same way? That we don't know. So, that is another good question.
If it does, then you could call us bird brains. Because it be found in chickadees first. I'll be here all week.
Being called a bird brain is a compliment.
Maybe okay.
It's great. It's a total compliment. Oh my gosh. Do you remember Zoolander? Was it Zoolander? Oh,
I remember Zoolander. What about Zoolander are we remembering right now?
The itty bitty teeny cell phone that Zoolander used. It's a tiny cell phone. It was making a joke about how technology and cell phones were just getting smaller and smaller and smaller at the time.
Tiny. And then they built the tiny little model of the school for him. What is this? A school for ads?
Yes.
Yes.
So we want to make things small. We like making things smaller and smaller and smaller, right? Yes. And with technology, that is also the goal. Because if you can make the components of technology smaller, maybe you can stick more components into your technology. And some of those things are transistors. Transistors are the off-on switches, right? That allow when electrons flow, it's like there's an off and there's an on. And there is the Moore's law, which is based on the materials that we use and the size of electrons and what we know about electron flow and quantum dynamics. There is a limit to how small our transistors can be. And we're running up against that limit currently. And so researchers are trying to figure out how to get past it and how can we, because what happens is at first it's like electrons are super nice and they're like, oh, no, after you. No, after you. And they like to, they flow and they're like going one after another. And it's like they go through the transistor. It's off, it's on, it's off, it's on, it's off, it's on. And everything's nice. But then you make the transistor smaller and smaller and smaller. And then the electrons are like, oh, I'm going to bump into you and I'm going to bump into you. And oh, forget it. I'm just going to make my own pathway. And so they start quantum tunneling. And so there's errors and there's a lot of problems with the smaller transistors because of the way that the electrons interact with each other at this quantum scale. It's no good for the technology.
It is not good. You're sounding like the Siberian tit now. It is not good for the technology.
It's not good for the technology. You know, you take the technology and you make small the technology, and it is not good. So you must make big. Make this big. All right, the technology, these transistors. What are we going to do with the transistors? How do we make them smaller? How do we get more transistors without producing too much heat, without having too many errors in the data messages that are getting sent? How do we do this? Well, some researchers just published their paper in which they're using, based on organic chemistry, molecules that are similar to hemoglobin. Zinc porphyrin is the molecule that they have used, connecting it to graphene. Graphene is a carbon-based component, structure, matter. My words just went away. But graphene, it is hard to control exactly how it is. It's like graphite, the carbon-based aspect of our pencils, but graphene needs to be structured very specifically for things to be able to attach to it and to flow through very specific channels that are put into the graphene. And then in addition, you have to be able to add electrodes to either end so that, positive, negative, and then you complete circuits and can have that current that gets created in the moment. All right, so we have the problem with the small transistors. In this particular case, they used zinc porphyrin because the researchers thought, really, nature has solved a whole bunch of these things, and electrons flow in interesting ways along molecules or are held by molecules all the time. So, why not try using molecules that are found in nature and see if we can understand how electrons are will flow through them, are attracted to them or interact with them, and just see if it works. And so it took about 10 years of research to get to the point where they published this paper. And in it, they have taken two pieces of graphene, connected them by a single zinc porphyrin molecule, and tried to complete a circuit to test the transistor. And they indeed found that instead of the weird quantum tunneling behavior that the electrons weren't acting nice before, with the zinc porphyrin, the electrons are like, hey, how's it going? I like you. And the zinc porphyrin's like, yeah, hi, one at a time. And so the zinc porphyrin suddenly created what they're calling, it's an interference pattern, so that in the same way that light interference patterns or sound waves can interfere with each other. And so if you have a down wave and an up wave, peak and a valley, those will cancel out. So that electron quantum behavior suddenly, because of the zinc porphyrin, became regulated. And they were able to reduce the size of the transistor to well below where it is currently for most technology. They got really, really close to the ultimate limit. The channel length and the molecule just 2.1 nanometers long. And normally we've got channel lengths currently in transistors of 7 to 10 nanometers.
Wow.
And 2 nanometers is like what's thought of as the ultimate limit for getting electrons through a transistor ion channel.
So the zinc, that's really cool. The zinc porphyrin ring is interesting. So where else do we see porphyrins?
Where else do we see them? Tell me.
Hemoglobin is one of the big ones where we see porphyrin rings. So with that ring, you've got your do you have a picture of it even? Yeah. Yes. So there's a porphyrin ring in the middle. And what happens is if you've got iron, iron would sit right in the middle of where that X is, where the little red dot is. And the entire structure of the porphyrin ring bends when it binds to iron. But it can bind to different forms of iron, which is why fetal hemoglobin and adult hemoglobin are different. They bind to iron in different ways. So fetal hemoglobin is information. Fetal hemoglobin is better at transporting oxygen than adult hemoglobin is. So this is really important when you're developing, particularly if you can't really use your lungs to breathe. Where are you getting your oxygen from? You're getting it from blood. And fetal hemoglobin gets replaced and becomes mature hemoglobin over the course of the first 6 months or so of life. So you become really good at oxygenating for the first period of your life. So with all these changes in
conformation, right? Yeah.
Being able to use a porphyrin ring to have zinc, which can readily interact with other electron configurations, that's really great, and is probably why their transistor is being so successful right now. That's super cool, using something that biology had already kind of figured out in order to make a better transistor.
Yes, and this is one of my favorite things, when science uses what's already in nature as inspiration for our next steps in advancement, and figuring things out. But I mean, it's like, oh, nature already did that, but now we're figuring out why it did it. Okay, we'll do that too. That's great. Or we'll use it this way. So unfortunately, though, we're not going to see our little teeny tiny Zoolander cell phones anytime soon, because this is still in the lab and they haven't worked out a lot of the details about the electrodes and how to control the graphene. And making
Well,
everything work
goodness,
well.
because my little chickadee barcodes don't work very well, and I lose my phone all the time at the size it is. So please
Great.
don't make them any smaller.
Where is your cell phone? I don't know. My Barbie has it. It's fine. Um, yeah, but this suggests, though, that there is another pathway to reducing the size of transistors that's a little bit different than the traditional element way of silicon chips inside our head that we have been looking at historically. So um, yeah, this not only will potentially lead to new, smaller transistors, maybe, who knows, don't hold your breath anytime soon, but it's also going to give us information about how organic molecules interact with electrons and how energy, how current flows um, through organic material and various materials in our world. Material science. So cool.
Especially when you present it.
That's right. When I present it, it gets to be a lot of fun. But now we're going to talk about junk.
Junk.
And yes, and this is right up your alley. Not placentas, but embryos.
How dare you say junk is up my alley? My alley has been swept clean of junk.
See, I don't even mean things that come out of my mouth sometimes. Oh, dear gracious. So these researchers in Portugal, the Gulbenkian Science Institute that is in Oeiras, Portugal, have been looking at a receptor protein, TGFBR1, and this is involved in embryonic development. They have been looking at it in mouse embryos, and they wanted to see, like, hey, if we get rid of it or inactivate it, what does it do to the spinal cord? Spinal cord and the neural tube, very important for development into a fully functioning organism, mammal, vertebrate. And the graduate student who was involved in the study was like looking through the results and was like, I found something. This was not expected. And I think you want to see this. And what they found is that by getting rid in one case, and they followed up on this research, and this is where this paper came from, is that the mouse embryo, one of the mouse embryos, instead of having genitals, had 6 legs. It also had its internal organs basically on the outside of its body. So this isn't something that is going to turn us all into tardigrades or other very, multi-legged creatures in any way, shape, or form. But the question is why, why continue down this path of messing with the gene and altering these mouse embryos to see what's going on there. And in this particular case, the researchers have known for a very long time that 4-limbed animals, they weren't always 4-limbed. We've had lots of different kinds of limbs. We've had tails. We've had multiple limbs. It's been a whole thing. And the primordial cellular basis, so the group of cells that our lower body come from, our limbs and our lower legs and the genitalia, they all come from the same place. And they determined in this study that this particular gene, TGFBR1, is in charge of telling cells what they're going to do, whether they're going to be genitals or whether they're going to be legs. And so the question is, how is this gene involved in development of things like double penis in reptiles, reptilian hemipenis? We've got other organs that aren't legs. We have lizards that don't have legs and look like snakes. There are other aspects of the dysregulation of this gene that can interact with the immune system and lead to metastatic cancers. And so there are some really very interesting implications for understanding in the long term how the embryos of all mammals, vertebrates, humans as well, how they become four-legged or six-legged or with genitals or not genitals. And with the immune system as well, we know that the immune system impacts gene regulation, and the immune system is affected by sex hormones. And so there may also be some aspect of hormonal regulation that is involved in the body form of animals that have multiple sex forms. How does everything end up the way it is?
Well, we talked, I think the last time I was on the show a couple weeks ago, we talked about body planning and how certain segments are programmed to be in a certain way unless they're stimulated under other circumstances. So in this case, in mice at least, I think I did a quick read of this news article, and they changed the expression of TGFR 1 beta or beta 1 partway through gestation.
Right, at different times. Yeah.
Right. So mouse gestation is about 19 days. And you don't actually get embryo implantation into the uterus until about day 5. And the interaction between the fetus and the maternal systems, like that placenta doesn't fully come online until about day 12. So this is all fetal development because the limb buds are developing and they start to differentiate around day 10-ish. And for them to manipulate that, the limb buds that they manipulate, the genitalia, it's long been thought that penis, clitoris, other external genitalia organs seen in other animals are formed kind of on the same like limb bud differentiation. So they just went ahead and proved it. But they also showed that TGF beta, you can see that bulging belly in panel B. Yeah, the internal organs. There's other stuff involved at keeping your insides where they're supposed to be. So
right.
that
it's not just limb buds, it's also a whole thing.
Right. Well, it also makes cartilage. And if you don't have enough cartilage in that area, then you don't have an adequate abdominal wall. It can also stimulate fetal growth factor, which is important to development of the organs. So maybe they've got too much organ at that stage, and that's why it's coming out. So lots of reasons why, we're not going. I love that you said we're not going to become tardigrades time soon, because that's what it looks like to me. But
yeah, it doesn't seem,
which is a great name for a band.
Fetal tardigrade, yes.
Fetal tardigrade.
Oh my gosh, it's a prog rock band for sure.
Totally.
Totally.
Right. Body mapping, super cool stuff.
I think body mapping is it. Some people from the outside will be like, well, it's just where things end up. But in terms of developmental disorders and differences, specifically in humans, if we can find targets to address genetically or even therapeutically while in utero, or even in vitro during IVF treatments and processes, there is the possibility that we can have healthier, more developmentally, physically, morphologically stable and functional offspring moving into the future. Yeah.
especially if something is going wrong, can we manipulate that gene back into alignment? If it's a naturally occurring mutation, can we affect it, and can we methylate that region of gene expression in order to shut it down? Once we understand the mechanism of how things are broken, we can figure out how to get them right again.
Yeah, and I think that point that you brought up about methylation is very important because you don't want to necessarily perpetuate genetic dysfunctions that, even though you can fix them technologically, you don't want to have to keep doing that generationally over and over and over again. So, can you repair something so that it is then genetically the fixed, quote unquote, fixed? I don't want to be ableist, but um, the repaired
Yeah,
version then is perpetuated for better survival of a lineage.
right. And we don't want to go
Yeah.
into eugenics, but like
Mhm. No.
how do we improve human health safely in a way that still allows people to be the people that they were meant to be?
Yeah, and
Yeah.
allows people to, if they want to have kids, have the kids, right? To be able to do
That's the
that.
ideal.
That's the ideal.
And if you
Mama,
don't want to have kids, that's great too.
whatever. Yes, whatever you want to be doing. Yes. Okay, so let's talk for this last story of this part of the show. Let's talk about vision. Now, I have always complained about the flicker of fluorescent lighting. Back when we had CRT computer screens, I had to change the speed, the hertz of the refresh rate of the screen because it, if it was 50, it gave me like a headache to sit at a computer, and so I had to set it to 60 hertz because those were the only things you could do with your CRTs, 50 or 60. But anyway, flicker fusion frequency, that is a genetically determined processing rate of your visual system. And if you have a lower flicker fusion frequency, then you don't care about fluorescent lights. You don't see them flickering. It's all fine. And if you like old technology now or grew up like I did with CRTs, once upon a time, 50 hertz was fine. If you have a faster flicker fusion frequency, that means that your neurons are timed differently and are able to see quicker changes in lighting. And we've known that there are differences in individuals, in people for a long time. And we know that there are differences between species for a while. But this new study that has just been published in PLOS One, researchers put a whole bunch of people into some funky goggles to be able to measure their critical flicker fusion thresholds to really get a high resolution of the variance between individuals. And this image of the apparatus that they use, which is like a pair of goggles that's attached to a tube, like it's kind of like a pair like binoculars, or I don't know, like and then there's an encoder, a rotary encoder that flashes a light inside of it or a screen. It makes me think of something out of like 1950s like sci-fi movies.
I'm just saying, Google Glass got really hardcore all of a sudden.
It absolutely did.
The new
Uh,
Apple Glass has just gone extreme.
oh, extreme. It's so extreme. You can't even stand it. Like you have to attach it to the wall and then just walk up to it and stick your face in it. Or, it's on your coffee table and you bend over and put your face in the goggles. Anyway, this paper, I think it is very fun because what they are showing is that there is a real between, and also for women specifically, within individual variation. So they had a bunch of individuals that they looked at different times of day, and they used various stimuli at different flicker rates of these LED lights, and they used the dial to increase it by 1 hertz increments until suddenly the individual could not perceive the flicker and only saw steady light. And if the flicker fusion frequency stuff that I've been talking about to anybody here still doesn't make sense, if you think of it as movies with the film rate, 24 frames per second is the absolute brain bottom limit that we've got, where you can put moving images together and they appear, our brain turns it into a constant flow and puts the images together into something that approximates the real world. So that 24 FPS is basically like, that's why it's 24 frames per second, is to give us this really nice, good view of the world that's not real, but our brains go, yeah, that's real. That's great. 60 FPS, which is a lot of phones right now. I don't like it that much. It's a little bit too much, but a lot of people like it. But it's not about me. So the researchers looked at variation, and in the end, they determined that yes, indeed, there are individuals who have significant innate advantages. And so I think that is the big question, that we've had for a very long time. Is it learned? Is it something like when you talk about gamers who are faster and quicker and more able, or race car drivers who are able to react to things very quickly? Is it just they learned the skill, or is there some innate component? And this study has kind of twisted it, and in their methods been able to say that, oh yeah, there are some people who innately, their brains are wired to be faster than others. And so they have a natural advantage in terms of temporal resolution as we view our world. And so those individuals, so it's not just between species, like predator versus prey, which that's an interesting kind of question to dig into. But for gamers, for, like I said, different people who are into different sports, for certain individuals doing different activities, what does the difference mean to everyday activities, to survival? How has it impacted our evolution to date? How will it impact or our brain processing and things that we do into the future as we're using technology more and more and more? And screens are such a big part of our lives. I think these are really interesting questions. So the frame rate of our visual system in our brains is important. And the one thing that I thought was really interesting is they definitely found a difference in women over time. And so that, to me, I want to know more about that.
Yeah. I don't know how much we have the capacity to process. Like, at what point does the FPS exceed our ability to actually cognitively process what it is that we're seeing?
Right. Yeah.
It's like having a computer with only so much memory. You can throw it at me as fast as I can, but at some point I'm not going to be able to keep up.
Right. And so that's the difference between maybe, different individuals. And perhaps this is some aspect of different brain architecture for like
Right.
ADHD, or, these are not disorders. They are different architectures and different brain types, neurotypes. And for different people, some people are, perhaps the good hunters. And there was a study that suggests that people with ADHD might be good foragers because they're constantly looking for, like, oh, look at that over there. Oh, look at that over there. Oh, with the vigilance is
Evolutionarily designed in
Mhm.
order to complete tasks in the environment in which they were best accustomed to, which I think is another story that we're going to talk about tonight. So
It is, which we're going to keep moving forward because, oh my goodness. Did everyone else have a long day? It's been a long day, y'all. This is This Week in Science. Thank you so much for being here. We have a few more stories to go. I want to thank Dr. Jess Hebert for also joining me tonight. We have more stories, but before that, head to twist.org. Click on the Patreon link if you want to help support us in an ongoing fashion. You can choose your level of support, $10 and more, and we will thank you by name at the end of the show, $15 and more. And I think you get a sticker every few months, new stickers that Blair art, which is pretty cool. We've also got t-shirts as different rewards and thank yous for your support. Our Zazzle store also is full of merchandise that proceeds go to help continue keeping the show on the air. And if, you just want to get a friend to subscribe, go tell a friend today. Take their phone and use it to subscribe to TWIS, or take their phone and subscribe them to TWIS. But I wouldn't tell you to do that. Disclaimer. Consent, everybody. This is This Week in Science. Coming on back, Dr. Hebert. We have some more stories, don't we?
I'm super excited for this one.
You are. This story.
It marries together two of my loves of science in a very weird way. So I'm excited.
The weird is always good here.
Yeah.
We enjoy the weird, yes. And in this particular case, it is the secrets of the naked mole rat, a very weird species of mole rat. This mammal, it's a very odd mammal. It lives in little tunnels under the ground. It's basically blind. It doesn't have any fur. It has big buck teeth. It's so cute. Like, really, they are just so very, very cute. If you like that kind of naked mammal kind of thing.
We call them the sand puppies.
Sand puppies?
Isn't that adorable?
Oh, I love it.
Sand puppies.
Yeah, these sand puppies can live up to almost 40 years, which, if you were able to take care of them, it's like half the life of a parrot. So you're taking on a very large responsibility with this kind of a mammal. But why do they live so long? It's because they have a bunch of really interesting genetic differences. Not just that they don't have hair and they have these little tiny blind eyes and the big buck teeth that they use to go after the little insects and things that they eat below the ground. No. When they're underground, very often they are in areas with not very much oxygen because they're digging these little tunnels, and sometimes the tunnels collapse and they're stuck underground. Sometimes they're in areas where there is no oxygen. Think of it, no light. Their tunnel is collapsed. You're just digging, and there's no oxygen. How do you survive? I mean, suddenly your heart stops. You're deprived of oxygen in your blood because your blood's not pumping. That's going to kill a human, or it's going to be very damaging to a lot of cells in the human brain and body. And how can we be more like naked mole rats? This is the big question.
Said no one until right now.
I always ask the big questions. Researchers have published in Nature Communications this study of the Heterocephalus glaber, this naked mole rat, and the genetic basis of the resistance to low oxygen levels or hypoxia as a model of cardiovascular disease. They basically gave these little mole rats heart attacks and then looked to see what happened. And they found there are a lot of adaptations, that differences in glycogen, which is for glucose storage enzyme, and glycolytic ATP, which is also part of the energy cycling of cells and the metabolism that happen. And so cardiac ischemia is the damage or the lack of oxygen to cardiac cells. And whereas in a human heart, if there's no blood or oxygen getting to those cells that have clenched up and aren't pumping, aren't doing their work in the heart, those cells are going to die. And that's going to be scar tissue in your heart, and then your heart doesn't work as well anymore. But these mole rats were like, "What's up? I'm fine. Go dig another tunnel." Totally
I love
cool.
extremophiles. They're so wild. I studied archaea for my second rotation in grad school, and there are things mostly multicellular organisms that do things like flourish next to volcanic vents and
Yeah.
in arid conditions, and the mole rat is kind of the epitome of that. And their oxygen, one of the reasons why they survive hypoxia so well is going back to that porphyrin ring. Their hemoglobin's different.
Oh, interesting.
It's a little bit closer to fetal hemoglobin. It binds oxygen more efficiently, which is why they can survive without oxygen longer.
I want
Yeah.
that. I need to go.
We
Don't I have to
all.
go like live and have multiple generations of myself at high altitude to be able to do that? Or
Well, if you live at high altitude long enough, you get preeclampsia. So let's not do that.
no, let's not
Yeah,
do that.
that develops in your family line. So let's not.
Okay, fine. But what's fascinating is that this is giving us. This study gives us, again, as we talk about in you know biology and genetics and genomics that are interested in um, how we can use this information for human life extension, for treating heart attacks, for extending the life of individuals who have had heart attacks, for keeping people from having heart attacks who maybe have genetic mutations that make them more likely to have them. If we know what the genes are that are involved, and most adapted in this naked mole rat, sand puppy, maybe, just maybe, we can do some good for people.
Yeah.
And our dogs and our cats and other mammals that are long lived. But
They're such an interesting species. They are my second favorite weird rodent species.
what's your first favorite?
The spiny mouse, which is not a mouse. And they're crazy because if you give them like basically what acute kidney injury would do to hurt their kidneys are fine. They
But they're so
regenerate.
cute.
They regenerate limbs, and they are the only member of Rodentia that gets periods. They
Wait, what?
menstruate. Yeah. So
That's fascinating.
yeah, the spiny mouse.
So it's not a
There
mouse
it is.
though, but are they a rodent?
Uh, I don't think they might not be part of Rodentia. I may have misspoken, but they are. Oh, I feel like they are. There's a great lab at UW,
Spiny mouse
the
menstruation?
lab that studies spiny
Ooh.
mice.
Oh, these are cool. They can regenerate skin. They menstruate. They've got organ regeneration. What? I didn't know about spiny mice. And
They are a member of Rodentia. They are order Rodentia, a family Muridae. So they are mouse proper, but then they split off from there. Moose.
they're mouse adjacent.
They are moose adjacent for sure. But yeah, they are members of Rodentia. They're crazy. So yeah, two of my favorite things: extremophiles and weird rodent species together on this track. It's great.
Yeah. Did you have any other comments about the naked mole rat study?
About the sand puppies? No, I think that cardiometabolic effects are really interesting, and the other half of my mentor's projects. So I do pregnancy following recovered acute kidney injury and what that means for the pregnancies and then the offspring. And the other half of his interests lie in CACPR, which is cardiac arrest, cardiopulmonary resuscitation in mice, and studying how that affects their hearts and their kidneys and what things are expressed and how that changes the size of their hearts. We basically make we say that we're the only lab on campus with a 200% death rate because we give them cardiac arrest and then we bring them back.
And then you the morbid lab humor.
I know, but they are treated treated extremely well, and we follow all care protocols. But it's how we understand if you went through a heart attack what does that mean for the long-term outcomes for your organs, and what does that mean for how we can treat you better. So
Or
that's why
even
that
not, or even like you're talking about just kidney function, right? So you've got things like that you study, like preeclampsia and other issues that are related just to pressure issues of
yeah.
a fluid flow within the body. Um, you know, does preeclampsia impact heart function after pregnancy?
That's a very good question. We know that you are more likely, if you have preeclampsia, you are more likely to have cardiovascular issues later in your life.
Hmm.
As the gestational parent, you are more likely to have high blood pressure and cardiac stress. I think you are also at a higher likelihood for stroke, um, amongst other things. Yeah, so it's
So eat your
there's
vegetables and make sure you've got lots of fiber so your microbiome is happy and you have antioxidants and your stress is low and you sleep all the time, which I didn't. So
during pregnancy. I don't think anybody does.
nobody does.
No. No, that was amongst
Doesn't
some of the worst
happen.
sleep in my life.
Yeah. Oh, restless legs. Where do you
Yes,
want to go?
our kids are totally worth it, but
Totally.
and I don't know if they made the podcast cut, but on the live stream, both of our Kiki's son and my son both made appearances on the show. Um, we love them beyond reason, beyond science.
And they drive us to wondering where our reason went. And sometimes our emotions get the better of us and we might get angry.
Uh-oh.
But you don't want to, you have to be a good parent. You have to like model good behavior. And so you don't want to be the parent attacking other parents at the baseball game. What do you do with the anger that is inside of you? Boiling. There is a hypothesis that you should have a cathartic release. And that for some people, yelling or doing something violent to a pillow or throwing something or, not actually going through on the instinct to attack or hurt some other living being or person, but a cathartic release in which nothing is really damaged yet it is kind of a violent physical release of the anger. That's the hypothesis that has kind of been predominant for many, many years. However, we also have heard of, Daniel Kahneman, may he rest in peace, system 1, system 2, the thinking fast and slow. We have our fast emotional brain and our slow rational brain. And so we might come to anger very quickly. But then if you take the conscious effort to take a breath, count to 10, it might give you the opportunity to release the anger in a different way or let it dissipate. And so the researchers in this particular study, they did a meta-analysis and looked at a whole bunch of different studies. And they had people, they observed individuals as well to see what, if they were put in different groups. There was a total of over 10,000 participants. And really, what I love from the press release about this study is that the research was inspired by, in part, the popularity of rage rooms.
Oh, those are great.
I've
You've
never
been to
been to
one?
a rage room. I don't know what a rage room is, but I guess you go, you pay money to smash things, to be the Hulk. I mean, I don't want to do that for anger. I just feel like it might be fun. But
It was fun. I took my husband to one up in Vancouver, Washington, and they turned on a great soundtrack for us and handed us some markers and a whole room full of weapons, from crowbars to baseball bats and whatever. And we just got to smash like old plates and bottles and things. And we wrote, like, feelings or things that we wanted to go away on them and just smashed things for about an hour, and it was lovely.
Okay, so the
I do recommend.
question, yeah, so the question, so you took the feelings, the anger that you wanted to go away, and then you smashed them, and so it was this physical kind of like, I'm angry at you, go away. It's fun, cathartic, yes, but would you have perhaps had the same experience if you sat in meditation and imagined those things as helium balloons that you named and you let them loose
Yeah.
and you let them go on their own? Or,
There's
yeah.
there's been a lot of research into whether like screaming and letting things out actually induces cortisol response versus relaxation response. I'm reading a book right now called Burnout: The Secret to Unlocking
Oh,
the Stress Cycle.
those, yes, that's a great book.
And in the
Yes.
first in that first section, so it's twin sisters
Hmm.
who one teaches women about burnout and the stress
Yes.
cycle, and the other one has gone through it, like has been hospitalized with extreme physical manifestations of stress. So they wrote this book together. And they say you have to complete your stress cycle and you have to go and do something physical and get it out. But I feel like the biggest changes that have come when I have faced frustration or adversity is like doing something and getting out of your body is important. But I feel like things like yoga are better than punching things. For me, that is
For
my personal
you.
experience. But I will
Yeah.
say that smashing things with a crowbar is super fun. And I do recommend doing it in the safe parameters.
I'm always going to have fond memories of the day right prior to going away to college that there was a car that a renter on my dad's property had left behind, and my dad had a backhoe, and he let me drive the backhoe and destroy the car with a backhoe. And I flipped the car. I smashed the windshield. I tore the hood off. That car was a wreck by the time. I mean, I got to drive a backhoe. I got to smash a car. I wasn't angry. That was just fun.
Yeah,
So,
people love going to monster truck rallies for the same, or
yeah.
demolition derbies. But I, if you're feeling rage, I don't think that you
Mhm.
should get behind the wheel.
No, road rage is
So
real and it is a problem.
yeah, or even at a demolition derby, something that because you aren't fully in control of your emotion at that point. So
Right.
it's a different can of beans.
Yeah. So with this study, what I think is very interesting is that they analyzed over 150 studies. They also had looked at the different things that individuals did. So meta-analysis, and they determined that the more meditative and like still physical but different release of the emotion was more effective than arousal. So,
Yeah,
arousal decreasing activities were better than arousal increasing or maintaining activities. And so it depends on, individuals. If you are the kind of person where going for a run is meditative, then that might calm you down.
but
But
if
if
you
you
hate
are like,
running,
if you hate running, I'm gonna go.
I'm gonna get my rage out by doing the thing I hate. Well, then no. But if you like, stretching, yoga, doing,
Mhm.
walking your dog. Uh, one of the things in burnout was they say, kiss someone you like for 6 seconds because
Oh,
it is a physical activity, and you don't kiss somebody that you don't like for 6 seconds,
no,
and it
that 6
slows that.
seconds is a significant amount of time.
Yep. So it slows your brain down a little bit. So I tested this theory the other day. My husband loved it. He was a big
I'm
fan.
sure he did, yes.
I was like, "I'm
He's like,
sorry.
"Great." You're like, "I
This is
need
for
to change my
science."
mindset."
Yeah. Yeah, and you
Thank
know
you.
what? Yeah, it does make you like it gives you that connection, and it does like help complete that arousal response. So
Yeah.
cool, right?
Yes, and I think that we need to remember the bottom line here is that we are embodied psyches. So it's not just our brain. Our emotions are not just in our brain because things have come in and made our brain mad. We feel it in our bodies, and our bodies are part of also releasing it. And so, whatever it is that you do, this particular study suggests that, yeah, beating things up and venting, screaming, arousing yourself into is not the way to do it. But that is not saying that you should not still be mindful of your physical body and the way that the emotion is impacting you.
Being angry is okay. The way that you handle it, that's on you.
Anger is a sign that a boundary is being crossed and that you need to make more specific limits. Anger is something you're mad because somebody did something. Yeah, anyway. Okay.
Welcome to This
Top
Week in
flight.
Therapy with
Yes.
unlicensed therapists Dr. Kiki and Dr. Jess.
That's right. Oh my goodness. We have just a very quick couple of stories to finish out the show. So, are you vegetarian, vegan, eat meat? How do you feel about the sustainability and the impact of the meat and leather industry on our planet?
Well, way to put me on the spot.
Yeah,
I'm
yeah, just putting you
I'm
there.
I'm an omnivore. I think that there's room for lots of things in my diet, but I'm also a big believer in using all the parts. So, use all the parts of the cow, use all the parts of the chicken, and we do try to replace some of our meat with other protein sources like beans and that sort of thing. But we definitely red meat is a good source of iron, and as women, especially women who are premenopausal, uh, sources of iron are very important and sometimes
Yeah,
hard to come by inexpensively. So red meat's kind of a good way to do that.
it is, and it, until we all end up eating insects, that's just where we are. But there are places that sustainability can be altered in the way that we develop different materials. So, yes, full circle use of animals. Highly recommend. If the meat is being eaten, the other parts of the animal should also be utilized.
Yeah.
But there's a lot of stuff, resources that go into growing an animal over a lifetime, years to get a cow or a year or so to get a pig to or a goat to wherever it needs to be versus, I don't know, a couple weeks to culture a vat of bacteria to create a substance that's not bacteria, but is cellulosic chains that are like leather and
Hmm.
that can also color themselves using like melanocytes. So that the bacteria could be grown to create fibers that it's still vegan, even though I mean that's what the researchers are saying. But essentially the material is created by the bacteria. In the process, the bacteria also are like, oh yeah, we're gonna make that brown. That's gonna be black. It's gonna look like alligator skin. It's gonna be black leather. Um,
Huh.
and they just published their study in Nature Biotechnology, and it's it's a really promising study, and it goes to show how far we can take bacteria to create potential solutions for the future, so that we can have materials that might work for us. So, for instance, they were able to create flat sheets of this leather-like material from the bacteria, black leather, sew it together, and create a wallet.
I wonder how well it holds up under, like, if it's durable.
So the thing, it is durable, and that is one of the things that they were also looking at, is because of the cellulose. It's also it's going to be a, a good replacement for the fake leathers, the pleathers that we
Yeah,
already use, but that
'cause that
that
doesn't
come
break
from
down.
fossil fuels.
Right.
Yeah, so they come from oils. And one of the super fun things that they created, that they created a mold and grew a shoe using the bacteria. They created a mold and used it to grow the bacteria in a way that they grew within the mold parameters and released the cellulose, and they stuck it on a cushy sole, and so it's a pleather, black pleather, little mid ankle boot.
With toe grooves.
But could you imagine, you take a little, you could do 3D scans or even a reverse wax casting of your own foot, and potentially with this technology, doing, if you're a DIY biologist, this is the kind of thing you could create a mold of your foot and make your own shoes.
I mean, kinda cool, but also just kind of gross. I don't know, there's something about it that strikes me as being inherently icky.
Well, I mean, the shoe that they've made, it's, it's pleather, and it's like, those the jelly shoes, the jellies that were once really popular, except they don't
Oh,
have
yeah.
this particular shoe doesn't have any holes in it for for breathing. So you stick your foot in it, it's that foot funk is just going to stay in there and
Uh,
not go
oh,
anywhere.
okay, now everyone can see the face I'm making. You know what? I think it's very promising in that there are probably things that we currently make out of plastic that
Yes.
could definitely benefit from being remade. And yeah, if there are leather like things that would benefit from this process too, that's great. As long as there are still people using cows, though, I feel like we should still be using the leather. And
Right.
leather
This
is
isn't going to
classic
completely
for a reason.
yeah, it's not going to completely replace it. Absolutely not. But in terms of the things that are coming from fossil fuels or other less sustainable sources, this might be an alternative moving into the future. They won a £2 million grant in funding from the Biotechnology and Biological Sciences Research Council, part of the UK Research and Innovation uh, granting system, to use this engineering biology and bacterial cellulose to solve more problems in the fashion industry.
That's
Because
pretty cool. Well, we live in an era of fast fashion.
yes,
So, yeah, but we also need to retrain ourselves to
be
stop doing
slow.
that. Yeah, buy things that are going to last a little bit longer if you can. But reuse and recycle. Places like Poshmark and ThreadUp want
Mhm.
you to reuse your clothing, so do that.
Ridwell, you can donate your used threads, which is, clothing. It's, you put it in a bag, they take it away. They use the fabrics from all the things to create, to recycle into new fabrics and new items. It's another recycling thing. But anyway,
Love
yeah,
it.
plastic based leather and leather. They're also not just like where they come from, but also there's other chemicals involved that aren't great and awesome. So, potentially this is more sustainable and a cleaner way to move forward in fashion and in other directions. Bacteria for textiles. But what about a robot who mimics you Have you ever played that game where you try and play mirror and you do what the other person's doing and you try and like predict what they're going to do like so you're doing it at the exact same time
Oh yeah,
and
your
mirroring.
neurons are crazy. Yeah.
And so yes, we know that now we have mirror neurons. There's a whole brain synchronization that occurs when you interact with people, even through something like this video stream as we're talking to each other and connecting and I'm like, okay, she needs to go to bed. We are connecting and synchronizing on topics and ideas and able to have a conversation. And the reason that we can converse is because our brains are predicting what might be said next, what could be coming next, whether you're going to smile, whether you're going to frown, are you going to be happy, whether you're not. And our brains are wonderful prediction machines, but so is the algorithm, the generative algorithm that is trained on facial expressions to learn how to express itself. Researchers at Columbia Engineering have built a robot named Emo. Cute
Oh.
emotion, Emo. And they have used a nice soft silicon material to make it have like a face, and it's got little cameras in its eyes, but it can make eye contact. And they're using a couple of artificial intelligent, machine learning algorithms to monitor facial expressions and predict future facial expressions in humans that the robot face might be interacting with, and then to be able to create its own facial expressions in synchrony to mimic the people that this robot Emo could be connecting with. So
cool.
Emo.
Yeah.
Yeah, Emo could be cool. The researchers, like, they're really like the press release for this one is great. I mean, this is Science Robotics is where it is published this week, but this robot, they foresee this robot being able to interact with humans as an advanced general intelligence embodiment. So the idea is that artificial intelligence, when it gets advanced enough to be its own thing and sense itself and interact with others in the way that humans do, the sociality and sense of self and theory of mind kind of stuff, this kind of robot, that Emo, is going to be the body that will interact with people. So Emo creeps me out. So Emo has been created by this wonderful engineer, and they've taken this robotic head with the camera eyes, and they've designed this robot that can observe people's facial expressions and make its own facial expressions. And the timing in talking to people is everything, isn't it? So, we have the uncanny valley, and this robot definitely is still within the uncanny valley area of interaction with people. But they've created this eye contact, so the cameras can look at you or whomever. It can make mouth movements. It was placed in front of a camera and a screen, so initially it trained itself. It just practiced making facial expressions in front of a camera, and then it saw itself. It self-supervised its own facial learning. Like, how do I move my face? And it started learning. And that was part of the first algorithm, the movement and what movements, what sensors and motors and servos need to be moved to enable certain facial expressions. And then there was the step of training with people and individuals. And so the robot then learned to predict if someone's going to smile and can actually predict if someone is going to smile up to, I think it's 840 microseconds ahead of when a person is going to smile. So the robot is fast enough and sensitive enough in its detection of micro expressions and the emotions that are involved in facial movements at this point in time, that it is able to respond like a mirror.
Amazing.
It's absolutely amazing. I mean, this to me is the not microseconds, milliseconds. I apologize. So Hod Libson, who is leading this whole team, yeah, they're trying to figure out how to create a robot that can really interact with people in a naturalistic way and embody future artificial intelligences.
I think it's already doing better than I am.
I mean, we know children learn from observing their practicing them and observing people around them. And so those games of big expressive facial expressions, as part of how a human brain learns how to express through the face.
Well, fantastic. Science.
Robo mirror, science, engineering, all the things together. Will emo be Jude Law in the future? Maybe. Who knows? We'll get there. I don't want a robo mirror. But it's time for bed, yes?
Definitely.
Yes. We have done the science. We have talked the things. Thank you so much for joining me tonight. I really appreciate getting to talk about all this stuff with you.
Anytime. It's my pleasure to be here.
Everybody out there, thank you for listening, for being here for the show. If you're in the chat rooms, really appreciate you being here to chat. Those of you who are in our Discord, who are Patreon supporters, all your gifts and images are really appreciated. All the comments have been fantastic, everybody. Aaron Anathema is really looking forward to you getting to episode number 5, Jess. And
let's figure it out.
Let's figure that one out. Shout outs, definitely, beyond our chat rooms, which I've been watching on Facebook, Twitch, and YouTube and Discord. I also need to thank Fada for his help with social media and show notes on YouTube and other places. Gord, Arnlore, others for making sure our chat rooms are great places to be. Identity 4, thank you for recording the show. Rachel, thank you for editing the show. Jess, thank you for joining me. PDX Broadsides, etc. If people want to keep following you, I know you have said this in a previous episode, but where can people find you more?
So you can find me. I'm Dame_DNA on Twitter. I'm also on Blue Sky. I'm on all the social medias, but you can follow the PDX Broadsides on Facebook and also pdxbroadsides.com for the next place that we'll be making music about science and space and Shakespeare and Nathan Fillion's bum and a million other things.
A lot of things. So yes. And your head is framed by Carl Sagan and Bill Nye. That's fantastic.
Yeah. These are both done by Christopher Herndon, who's a Portland-based artist, and he did a whole beautiful science series. He's also got a Stephen Hawking, and yeah, he's fantastic. Dane Alt is another one. Monkey Minion Press.
I know Dane Alt. Yes, great. And
yeah,
great.
So he was here in Portland. He's in Kansas City now, but he did a whole book called Eureka about 30 lesser-known scientists, and he does all sorts of space and art prints. So I love science art.
Yay! Let's have more of it. I don't know if I like it either. I don't know. I'm surrounded by it right now. For those of you who only listen to the podcast, I love science art. Let us finish this out also by thanking the Patreon sponsors. I absolutely must thank all of you who support the show. So a big thank you to Alan Viola, Aaron Anathema, Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Kent Northcote, George Corris, Pierre Velazarb, John Ratnaswamy, Chris Wozniak, Vagard Shefstad, Nathan Styles, a.k.a. Don Stylo, Ali Coffin, Reagan, Shubru, Sarah Forfar, Don Mundus, P.I.G., Stephen Alberon, Daryl Myshak, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minish, Johnny Gridley, Remy Day, G. Burden, Lattimore, Flying Out, Christopher Dreyer, Audium, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Rick Remus, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Knowles, Dave Neighbor, Eric Knapp, Lon Makes, EO, Adam Mishkan, Kevin Parachan, Aaron Luthen, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you so much for all of your support on Patreon. And if any of you are interested in supporting us on Patreon, you can head on over to twist.org and click on that Patreon link. On next week's show, I don't know, Jessica.
Well, who will you be speaking with?
I don't know yet. I don't know, but I'll be,
magic.
I don't know. It's magic.
This Week in Science will be back on Wednesday at 8 p.m. Pacific Time, broadcasting live from Twitch, YouTube, and Facebook.
Indeed, we will. And if you want to listen to us as a podcast, just look for This Week in Science every place that podcasts are found. If you enjoyed the show, make sure you get your friends to subscribe too.
For more information on anything you've heard here today, you can find show notes and links to the stories that we read today. They will be available on twist.org, and you can also sign up for the newsletter.
Woohoo! Sometimes we send it out, but we also love your feedback. So if you love the show, or if there's just a topic you want us to talk about, or a story you want us to cover or address, a suggestion for an interview or another guest, please let me know. Send me an email or, hit me up on the social medias. But if you're sending me an email, make sure you put TWIS in the subject line, because if you don't, your email will be spam filtered into a hypoxic, naked mole rack, sand puppy collapsed tunnel, and it's never going to come back out. So just put TWIS in the subject line.
Are we ready?
Yeah, we're ready. Are you ready?
Well, we look forward to discussing science with you again next week. And if you've learned anything from this show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.